intensive soil investigations to ensure that the anchor that you want to use will work. So if you're an area that has a lot of very soft mud, your suction caisson could work there. But if you're in an area where there's outcroppings of bedrock or very hard materials, then you may not be able to use a suction caisson. You may have to drill and socket or have a very aggressive sort of drag anchor or torpedo anchor that works there. So for our research, we usually try to stay anchor agnostic. In our particular research project that I highlighted for CEC, we looked at both VLAs or vertically loaded anchors as well as suction caissons. And then for our project in Maine, those utilized, and I think you probably saw the photo of myself standing next to some drag embedment anchors. And that allows us to use the semi-taut configuration where we pull horizontally on the drag embedment anchor instead of pulling up. So each anchor type is site specific, and then your mooring system can fall out of what your soil conditions are locally.
Great, thank you.
Brian, you have a question?
I do. Thanks for the presentation. It's fascinating. Trying not to geek out here, but as you're moving forward, and particularly with your demonstrators, maybe do you have any comments for us on sort of failure mode analysis that you might have already undertaken? And specifically, I was very intrigued by your comments about sort of an array of shared cables and what that sort of means. So I guess like for the individual installation and then for an array installation, what kind of failure mode do you see there?
This might be good to be backed up, Lars, with your opinion, but according to the design codes, we look at various levels of both extreme and operational conditions. So according to the ABS floating offshore wind guides, we look at both the 50 and the 500-year storms with different load factors to see what the effect of the site-specific environmental extremes are. And then we even look at the condition in which the turbine is operating in a 50-year wave environment associated with that. For a fully redundant system, it has different load factors than a non-redundant system would have, with the caveat being you have to check the condition of one of your mooring lines being failed to ensure that the system still has the station keeping that you're planning on. So we look at that failure mode addressed as well. And that all boils out of what the intended reliability according to the design codes are. And that might be where, Lars, you might be able to handle that. But basically ensuring a level of safety across the board that matches what's expected.
Yeah, I'll say I said a couple of things into that. So I'm involved in the development of the IEC international standard as well. And these standards are not considering commercial risks so much. It's more for the environment and the integrity of the units. So we do allow, for example, this one line broken condition. But if you do have a 3-line mooring, that thing and 1,000 meters of water depth, that thing will take off far, far away. And the cable will be really unhappy. But that's a commercial risk. We make sure it doesn't bump into the other next door unit, but cable, it's up to the risk appetite of the developer. And that's important to keep in mind.
And for these complex, sorry, Lars, for the complex systems where you're sharing mooring lines, I have a paper from 2018 where we look at the system reliability. So if you're interested in that, shoot me an email and I'll send that paper your way.
But also looking at history, the mooring line failures, because lines will fall off. We know that from past experience with oil and gas. But it's mainly driven by mistakes during fabrication or during installation. It's very rare that a design mistake cause a mooring failure. So it's important to be involved in all parts of the development, not only the design, but also the fabrication and installation.
Okay, good. So that, well, thank you very much, Spencer. That was informative and really helped the committee out. Next up, we've already heard a bit from Lars, but Lars Samuelson, he heads ABS's global offshore renewable efforts. And Lars, you're on.
Well, this is hard because Spencer took all the fun and sexy parts of it. So let me see if I can share the screen here. So can you see something now?
Not yet, because you're getting close coming. There we
How about
go.
now?
Yes.
Yep, excellent. So I'm Lars Samuelsson. I work for ABS. Been with ABS for a long time, background in oil and gas, and I've been doing wind since 2008. I think it was a NSA meeting in DC that sort of was the start of the whole thing. So ABS, we are like a third-party verification body. Was put in place by insurance companies just to understand the risks they took by insure certain ships and vessels. But our mission is to protect security of life, property, and the natural environment. And we do that by verifying design and the construction and the operation of a unit in the marine environment. And we are still a non-for-profit organization. So no owners, no nothing. And the experience we have had going back to 2012, when the first little demonstration unit, it was a 2 megawatt unit offshore Portugal. Later, it was relocated to Scotland to span there for a year. Then we have the 25 megawatt Windfloat Atlantic, which are 3 units with 8.4 megawatt turbines on. And the last one we did was the Kincardine, which is 5 turbines. I think it's like 9.6 megawatt there. And you can see this acronym, the thing that starts with the Maltese cross A1, which means that we actually class the units, similar to what you do for a ship or a traditional oil and gas unit, but considering the special risk profile of an unmanned structure with limited pollutant on board. And actually, even more interesting, with the Kincardine, we flagged it, which is something you normally just do for vessels, but it fitted really well into it. So that's enough of our experience. If we're trying to draw experience from offshore wind versus traditional offshore, you can see for floating wind, it's a lot more commonalities with traditional offshore. We have anchors that is directly transferable. Although for renewables, we do see some new inventions with micropiles, etc. Moorings, we have in traditional oil and gas, there is probably 20 years of experience from synthetic moorings. Structural integrity, similar. Structural loads are different though, because now we have a horizontal payload instead of a vertical payload, and we have a control system of the turbine that are driving it. So that is very unique. So that's more similar for what we have for a bottom-mounted turbine. Stability, little bit the same, little bit different because of the loads. Systems is very limited systems, and you do want to minimize anything rotating on an unmanned unit because you don't have the opportunity to maintain it as you would if you had people on board. Fabrication, these are a lot more complex than a monopile. And as of today, they have been done in traditional shipyards, not in facilities designed to fabricate wind turbines. As we go forward, when we start to see more developments, I foresee it will be a lot more specialized facilities with automatic welding, etc. And then when it comes to installation, it's the same thing. You reset the mooring system, on a sunny day and then hook up the unit on another day. So to regulate all of this here in the US, this is under BSEE now, through that 30 CFR 285 for anything that is on outer continental shelf. I think Spencer's project he talked about, that one is in state waters or a research lease, one or the other. Spencer?
State waters.
Yeah. So this does not apply necessarily to that unit. I didn't talk about the little one. I talk about the research array, by the way.
Yes, research array is a little different in that it's a federal water research lease. So not a commercial lease, but it is a federal project.
Yes, but you don't have to apply with the 30 CFR 285, right?
We do not, but we do have to comply with all other permitting activities that are required.
Yes. So this 30 CFR comes in after basically all the environmental permitting is done. So this comes in when you select the CVA, you will report to BSEE. And I realize I have not updated this slide, so my apologies. It says BOEM there. It should say BSEE. Verifying the design, verifying fabrication and installation, and state to BSEE that we believe that the CVA believe in the unit. And it kind of a unique position because the developer is paying the CVA, but the CVA is reporting to BSEE. So to visualize this a little bit better, and I used the slide that I have for our guide because we have developed the floating wind turbine guide that is aligned with this IEC document -3-2 that BSEE expect compliance with, that address the floating structure, systems, mooring system. For the turbine, they usually comes with a type certificate. So you just verify that it is within the design envelope of the certificate and that the loads imposed by the turbine are properly accounted for in the analysis. And I had some space over so you can see how large these units are. They're probably 60 meters above between the columns. So they're fairly massive units. So a little bit about the involvement from the CVA that would be under design, verify all the design aspects of it, fabrication, and that will be interesting in California because of the limited opportunities to have a large fabrication facility there. I mean, you have NASCO, but they have better things to do or more profitable things to do, I would say. So most likely it will be a split fabrication that the main steel is done in Asia Pacific somewhere, shipped over, assembled, and then probably you would need a staging area after it's assembled until it can be installed somewhere semi-offshore and then installed offshore. And now if you go down the class route rather than the CVA route, class is a life cycle approach. So it also includes survey during operation to see that it age as expected and they don't have any main issues with the units. And that was the only few little points that Spencer left for me. So I think we have a lot of time for questions now, again.
Yeah, thank you, Lars, very much, and for both of you for your presentations. And just before we start with questions, you know, Lars is pretty knowledgeable about all aspects of the wind because ABS approval covers more than just the structure. So, you know, feel free to ask any questions you have in mind about the technology, and if Lars can answer them, he will. So I'll lead off with one. You know, I understand that these turbines can be very quickly shut down, controlled, you know, it's their feathering for bad weather, etc. And this question pertains to search and rescue. If it became necessary to shut it down, technically you can do it very quickly, but for these really large capacity plants, I'm not sure the grid can handle that. And do you have a sense, Laura, as to how quickly turbines can be shut down if it was needed?
Well, most likely they would not all shut down at the same time. There are different types of shutdown. You can pull the emergency brake, but you don't want to do that because you impose really high loads on the structure. But the controlled shutdown is more of a dragged out procedure, so to say, and you can feather the blades, right? See, to some extent, you can adjust so you don't just have the 1 or 0 into the grid. Oh, Spencer.
Yeah, I agree. There are more, I guess, gentle operations that you can do, and it depends, on your site specificity, and what the wind condition is at the time that you may need to do this operation. If you're cranking along with a 12 meter per second wind and you're generating your 15 or 20 megawatts at your one plant, you're going to want to feather the blades slowly. As Lars said, there's a lot of inertia in the system. However, we do check that load. We do check the e-brake pull. And like Lars said, there are large loads that are imposed on the entire structure. The blades, the tower, and even the moorings see those loads as well. So you do have the ability to shut everything down if you need to. My understanding is there isn't a person in a control room somewhere who has their finger on the red button at all times, but there is the capability to shut everything down remotely. And you can do it on an individual basis or a plant-wide basis.
And done on an individual basis in a controlled manner, are we talking minutes or hours? What's in?
The
Minutes.
Yeah.
If you hit the emergency brake, you're talking minutes.
Okay. All right, that's my question. Robert, you're next.
And I don't, this is not necessarily specific to the hulls or the moorings themselves, but just from a installation perspective, is anybody considering installing the hulls and moorings separate from the turbines? Or is everybody thinking we're gonna set this whole thing up in a, as Lars said, a semi-offshore environment and then dragging the whole thing out? For instance.
Yeah, you don't want to install the turbine offshore. You can avoid it because then you have 2 moving bodies and you want to fit something on top of a really high pole. And it's most expensive to have a vessel like that. And it's also limiting the weather window where you can install it. So the trend is now to install it at the dock with a crane, or now we start to see different devices that may be able to replace a crane to get the turbine and the blades installed and then tow it out in one way or another.
And then the kind of going thinking now is, at least for the many megawatts up to the gigawatt scale deployment offshore, is that all of the moorings will be pre-laid in advance of the first floating turbine arriving. And again, that's because, as Lars said, those vessels are very expensive to have on site. There are only several vessels in the world that will be able to handle, at least for the 15 megawatt or 20 megawatt turbines that everyone's talking about now, the types of moorings that will have to go in. So you send that expensive vessel out and get that work done as fast as you can. And then, maybe the next spring or early summer the following year, you start towing out your first floaters that have been constructed and have smaller vessels do the actual hookup then.
And I mean, we can use high wind Scotland as an example. There was 5 spar buoys. which are really deep draft units that had some issues with the turbine. And their preference was to unhook them, tow them over to Norway, where they had a fjord that was deep enough, and then repair the turbine in a sheltered environment, rather than to try to do it on site. Because in general, it's fundamental. These are on purpose placed in a place with bad weather, right? So it's not, it will be windy there.
Yeah.
All right, thank you. Next question, Dave Checklin.
Yeah, thank you very much. I'm curious, what are the reasons that turbines have been shut down to date? Are they primarily technological or are they by chance involving birds? I don't know.
No, I haven't heard anything about birds. It's been more for the floating turbines. I believe. No, I'm a naval architect. I'm not a turbine person, but it sounds like it's more mechanical issues than anything else.
Thank
Yeah,
you.
the majority of shutdowns that I've read about are mechanical issues, increased O&M because we're still kind of at the pilot project phase. So there's a lot of inspections that are required that may not be, as prevalent in an entire farm. And then the cables have been a bit of a technical challenge because of course these are dynamic cables. They're moving around a lot. And those have had to be inspected, and I think in a couple of cases replaced, at least small sections of them replaced in service.
What, as we scale up to 25 megawatts, what's your confidence that that can be done safely?
I have higher confidence in the mooring of the hull than I have in the turbine. I would say, because I mean the foundations of the mooring are fairly easily scalable.
Yeah.
But the turbines are, I mean, they will become massive. And we already seen what happens now when we went up to 15 megawatt on bottom founded, and there have been some issues there. So, and going back, I think what made the land-based wind so successful was the industry decided to stop by this 3.6 megawatt or something and optimize that one. So it's hard. At the same time, you save a lot of money on paper to put a 25 megawatt instead of a 15 megawatt out there. So it's a balance and your risk appetite.
Yeah. Any other questions for our panel? Dave, one more?
I'm curious, in a wind farm, do all the turbines operate all the time, or is there a 80% operation rate and some are being worked on at times? I'm just curious.
There are a lot of cases where you'll have individual or groups of turbines shut down in the system, whether it be for maintenance or, an error code was thrown by the control or something like that. So there very often are situations where you'll see many turbines spinning and only one, or sometimes you'll see one turbine spinning and none of the others. That's very common. There was a question in the previous panel about capacity factors, and a lot of the floating projects like Kincardine and Windfloat all had capacity factors over 50%. So, as Lars said, we put them purposefully in locations where the weather is bad and the wind is blowing a large portion of the year. So the vast majority of the time, these floaters will likely be spinning.
One of the concerns raised by fishermen is the potential impact as you absorb all this energy on ocean currents and possible upwellings. Do you know, either of you, what type of research has been done in that area and what might be ongoing?
So I know Schatz Institute out of Cal Poly has a paper that looks at the array effects. Of course, the whole idea of the wind farm is to extract energy from the wind. And they've looked at, the wind is one of the primary factors in terms of upwelling as you approach the West Coast. And they've tried to quantify what the reduction in the upwelling is, because of course that's where a lot of the nutrient transport happens, and is an aggregator for a lot of the ecosystem for that environment. And I don't want to quote any specific numbers or values, but I will, direct you to Schatz Institute to look at that because they are the experts in the space. But from what I recall, it's not a devastating impact because of course the total amount or percentage of the energy that we're extracting on an array scale is only a couple of percent. We wish we could extract more energy than that, I think, oftentimes, but on a global scale like that, where we're talking about Pacific currents, it's a very small drop in the bucket. But I encourage you to go look at that research because they do a very good job at actually starting to quantify those effects.
Thank you. Any other questions for our panel? Hearing none, I'd just like to thank both of you for very informative presentations, and I'm sure we'll be back to you with a few questions in the future.
Thank you all.
Well, thank you for inviting. I appreciate it. Thank you.
Super. Yeah. Okay, we'll wrap up. We've got our tour. Can we leave early or should we wait?
It's gonna start at 3:30 down there, but.
Oh, okay, so,
Traffic.
yeah, we'll carpool, so let's gather together before we go. All right, thank you all.
There is also a snack outside, there's little pinwheels, so.
Good.
Bye, online folks.